The mystery of sound, life, science, and the universe.
Sound. It's not just sounds. It's the key to our lives, our science, and the mysteries of the universe. Sound is essentially vibration. When an object moves or shakes, it disturbs the particles around it, whether in air, water, or solid materials. These disturbances travel outward in the form of waves, and those waves are what we call sound waves. From a scientific perspective, sound is a mechanical wave, meaning it needs a medium to travel. Unlike light, which can move through the vacuum of space, sound cannot exist in space because there are no particles to carry its vibrations. That is why outer space is silent. Sound waves are usually longitudinal waves. In this type of wave, the particles of the medium vibrate back and forth in the same direction as the wave itself. Imagine a line of dominoes. When one falls forward, it pushes the next, and the motion continues along the line. Similarly, in sound, particles compress and expand, creating regions of high pressure, compressions, and low pressure, rarefactions. Two key properties define sound. Frequency. This is the number of vibrations per second, measured in hertz, or Hz. Frequency determines the pitch of the sound. A high frequency produces a sharp, high-pitched tone like a whistle, while a low frequency produces a deep sound like thunder. Amplitude. This refers to the strength of the vibration. Greater amplitude means louder sound, while smaller amplitude means softer sound. Humans can generally hear sounds with frequencies ranging from 20 Hz to 20,000 Hz. Below that is infrasound, which we cannot hear. Infrasound is sound waves with frequencies lower than 20 Hz. Although sounds of such low frequency are too low for humans to hear as a pitch, these sounds are heard as discrete pulses, like the popping sound of an idling motorcycle. Whales, elephants, and other animals can detect infrasound and use it to communicate. Above that is ultrasound. Ultrasound is sound waves with frequencies higher than 20,000 Hz. Ultrasound is not different from audible sound in its physical properties, but it cannot be heard by humans. Ultrasound devices operate with frequencies from 20 kHz up to several gigahertz. The speed of sound varies depending on the medium. In air, at 20 degrees Celsius, the speed of sound is about 343 meters per second. In water, it is even faster, about 1,500 meters per second. And in a solid material, like steel, sound travels at about 5,000 meters per second. We hear sound through a complex process. Sound waves first enter the outer ear, travel through the ear canal, and strike the eardrum. When the eardrum vibrates, the vibrations reach three tiny bones, the malleus, incus, and stapes. These bones amplify the sound and send it to the inner ear, where there is a snail-shaped organ called the cochlea. The fluid inside the cochlea moves, and thousands of tiny hair cells vibrate. Each cell detects a specific frequency. An electrical signal is created, which is sent to the brain via the auditory nerve. The brain interprets that signal, and we understand, whether it is music, speech, or the roar of thunder. Bats can hear the highest frequencies. They are able to hear sounds up to about 100 kHz. They use this ability to find prey and navigate their way through echolocation. Dolphins can also hear the highest frequencies. They can hear frequencies higher than 100 kHz underwater. This helps them measure distances and find prey underwater. On the other hand, elephants can hear the lowest frequencies. They can hear frequencies as low as about 16 Hz. They use this infrasound to communicate with members of their group who are far away. Baleen whales can also hear the lowest frequencies. They can hear sounds up to about 7 Hz. These low-frequency sounds reach far into the ocean, allowing them to communicate over great distances. Sound is used in science and technology in extraordinary ways. It is not only a medium of communication, but also essential in research, medicine, engineering, and entertainment. In science, the study of sound is called acoustics. It is a branch of physics where sound waves, vibrations, ultrasound, and infrasound are studied. Scientists use sound to understand the behavior of waves inside different media, including reflection, refraction, and energy transfer. In medical technology, sound plays a vital role. Ultrasound is used to see the internal organs of the body. It is also used to observe the condition of the fetus during pregnancy. In navigation and research, sound is indispensable. Sonar technology is used to detect objects underwater. It is extremely useful in submarines and oceanic research. The use of sound is also very important in space research. Sonification is a method of converting light waves, X-rays, or radio waves from space into sound. Through this, we can hear the roar of black holes, the explosion of stars, or the silent dance of galaxies. Some spacecraft, such as Huygens and Titan missions, have carried microphones. These have recorded atmospheric pressure and wind noise, which have helped scientists understand the weather and environment of other planets. Sound protects us, heals us, inspires us, and reveals the mysteries of the universe. Without sound, life would be silent, science incomplete, and the cosmos unknowable.